Hello. Okay, so we are going to start with conservation of momentum today. We're going to take a look at that. And then we're also going to take a look at conservation of momentum in 1D and some sample problems dealing with collisions. Okay, so this is 5.2 in the old textbook, Nelson Physics. Conservation of momentum in 1D. Okay. All right. So first things first, we're going to write down what the definition of conservation of momentum is. 1D, of course. You know, we're talking about linear momentum here. We're not talking about angular momentum or anything in as such. Okay. So the law of conservation of momentum says the following. It says if the net force acting on a system of interacting objects is 0, okay, then the linear momentum of the system before the interaction equals the linear momentum of the system after the interaction. Okay, so momentum before equals to momentum after. P equals to P after. Now, how do we prove that? So you don't have to prove this, what I'm going to do next, you don't have to prove this in a test. Okay, this is just an explanation of how momentum before equals to momentum after. Okay, all right, so what we're going to do is we're going to try to prove it, and this is on page 240 in your textbook. Can I erase this part? Okay. Okay. All right, and so we're going to start with M1 delta V1, which equals to negative M2 delta V2. Okay. Okay, so we're going to take a look at it and we're going to say M1 V1, which equals to, so this right here, we already did that. So this would be m1 v1 prime minus v1, which equals to negative m2 v2 prime minus v2. This is v2 prime. Okay. Now v1 prime basically means after. The velocity of the second object after, the velocity of the first object after. Velocity of the first object before, velocity of the second object before. Before and after, yes. Which line? This? This nothing. That is nothing. Okay? Alright, so what we're going to do is we're going to expand it. m1 v1 prime minus m1 v1, which equals to negative m2 v2 prime plus m2 v2. Okay, so now what we're going to do is we're going to take the objects before their interaction and we're going to look at the objects after the interaction. So what we're going to do is we're going to move this onto this side and move this onto this side. So this is going to become m1 v1 prime plus m2 v2 prime, which equals to m1 v1 plus m2 v2. In other words, we can switch this around because that's how I like to look at it, and this would become m1 v1 plus m2 v2, which equals to m1 v1 prime plus m2 v2 prime. Okay, momentum before equals to momentum after. Momentum of the two objects before the collision, momentum of the two objects after the collision. Are we good? So far so good? Okay. All right. So what we're going to do is we're going to do a couple of sample problems just to show how this works. And then we're going to go to the next section. Eight minutes. Okay. Can I erase it? Yes? All right. So as I said, you don't have to prove all this in a test. You just use this right here. Okay? All right. So let's erase this whole thing. And let's start with this one. Page 241. Old text. Sample problem number 1. And the question is as follows. It says a person of mass 75 kilos. So mass of the person is 75 kilos. Is standing on a stationary raft. So the velocity of the person and the raft, so velocity of the person of course is 0.0 meters per second. Okay, velocity of the raft is 0.0 meters per second. Correct? Then the person walks to one end of the raft. So the velocity of the person after, which equals to 2.3 meters per second, at 2.3 meters per second, relative to the water. What are the magnitude and the direction of the resultant velocity of the raft relative to the water? So what is the velocity of the raft relative to the water after this interaction? Neglect fluid friction between the raft and the water. Okay, so we're going to start out with m1 v1 plus m2 v2, which equals to m1 v1 prime plus m2 v2 prime. Okay, now we know this was 0 before the interaction. This was 0 before the interaction. So it's going to be 0, which equals to 75 times 2.3 plus and the mass of the raft was 55 kg. So this is 55 times V2 prime. Okay, so now what we're going to do is bring it over to the other side. This becomes negative 75 times 2.3 divided by 55, which equals to V2 prime. And you get a V2 prime, which is, what is it equal to? What's your answer? What do you get? Negative 3.14 meters per second. So this, basically it's a Newton's third law question, right? An action of the person walking on the raft causes a reaction in the raft itself. So this is 3.14 meters per second backward. So far so good? Make sense? We good? Can I erase it? We're going to do another sample problem. Yes? Okay, so 12 minutes. This is page 242, old text, sample problem number 2. And the question is as follows. It says, during a football game, a fullback of mass 108 kilos. So mass of the first player, so player 1, is 108 kilos, running at a speed of, so V1 is 9.1 meters per second forward, let's say, is tracked head-on by a defensive back of 91 kilos. So mass 2 is 91 kg, okay, at a speed of 6.3, V2 is 6.3 meters per second. In the opposite direction, of course. Okay, what is the speed of the pair just after the collision? So imagine that V1 prime equals to V2 prime, which equals to V prime. Basically, if you ever watch games of football, you got the big player getting a hold of the smaller guy, or the smaller guy getting a hold of the big guy, and then taking them together, sliding, tackling them, taking them together for a certain distance. So they both have the same velocity after the collision. Okay, they've joined together. Okay. So we want to find out what that after velocity is after the collision. So we're going to do m1 v1 plus m2 v2. Now we're going to change up the equation slightly. So it's going to become v prime m1 plus m2. Because after the collision, both the players join together. Okay. So we're going to do 108 times 9.1. Okay. Plus 91 times negative 6.3, which equals to v prime divided by 108 plus 91. Okay, so remember it's a negative here. So it's going to be 108 times 9.1 minus 91 times 6.3 divided by 108 plus 91, which equals to V prime. Okay, what do you get for your V prime? It's going to be, what answer do you get? Yes, 2.05, so it's going to be 2.05 meters per second. So the velocity of the pair after the collision is 2.05 meters per second. It's going in the direction of the first player, so forward. Well, because they're going in two different directions, right? You have player 1 going this way, player 2 going this way, so we can't add the two together. I mean, they're literally going in opposite directions. So you got to take that into account. And of course, momentum is a vector. Correct? Okay, excellent.